So in this video I'll be showing you how to factorise cubic polynomials in the first of three ways. Now in this video I'll be showing you how to factorise cubic polynomials using the fact theorem only and how to do this using your scientific calculator. Now, factorising a cubic equation using the fact theorem only might seem like a very easy option. However, this only works for certain polynomials. It only works when you've got single x's within your three brackets and also when you have got three brackets. So as time goes on and you're trying a range of questions, you'll find that that's not always the case, in which that is the flaw of this particular method. So what I'm going to do is I'm going to go through the method in which I recommend that you make a note of these, and what I'll then do is go through a few examples with some example questions of when it does work and also when it doesn't work. So the first thing you want to do is write down all the factors of the constant, including their negative value. So what this means is I'm going to look at the constant, which in the above case is d, and what I will do is I will write down all the factors of d. So for example, if d was, let's say, 3, then the factors would be plus minus 1 plus minus 3. So you want to make sure that you're using both the positive and the negative values of that. The next thing, once you've established a list, and there might be a list of numbers, and what thing you need to remember is that this first step will be the first step for all three methods I'm going to show you. So it's really important you start with that. Otherwise, starting with any number will again could be endless opportunities in terms of what you need to do. So once you've got those list of factors, both positive and negatives, the next thing you want to do is substitute these values into the polynomial. And what you're looking for and what you're going to refer to is the fact theorem. So what you're looking for is which values that when you substitute into your polynomial will give you a value of 0. So if it gives you a value of 0, then therefore that value is going to be linked to one of the factors. And as a little tip, it says there is always start with the smallest values. So if start with minus 1 plus minus 1, then start with 2's. So if you go up in that idea, you might find a lot easier rather than just picking at random, because like I said, if you've got a list of 10 factors, it might take you 7 attempts before you find the one. But the rule of thumb is you always start with the smallest one. And then what you're then going to do is, like I said, is using the fact theorem of that, when you substitute a into your function equals 0, then x minus a is going to be a factor of one of those brackets. So for example, if let's say you substituted positive 3 into your polynomial and the polynomial gave you a value of 0, then x minus 3 would be one of your brackets. So if your value you substituted was minus 1, then x plus 1 would be one of your brackets. Now, using your calculator to do this is quite a useful tool. Now, there are a range of different scientific calculators that you may have. Here in the UK, it's advised that students have the Casio FX991EX calculator, which I have to admit is quite an advanced calculator for scientific calculators. I've been teaching for quite a while, and this is quite a powerful and useful calculator for you to use. Also, there's graphic calculators as well that you may be encouraged to buy from your maths teachers, but definitely in terms of capabilities, the Casio FX911 EX is a decent one that I definitely recommend. Now, if you've got a normal calculator, then I'll show you how to access these. Obviously, different calculators have different modes, and what I'm going to do is just use the Casio ones because they seem to be the most popular. But if you have got another calculator, I'm sure if you look through the manual or go onto YouTube or on Google, I'm sure you'll find access to this particular method. So on your scientific calculator, you should have a table mode. And this can be found on the Casio code by pressing either mode setup or menu and then selecting the right option. Now, once you've gone into those modes, you'll have a series of options that you have to input some data in. So your first step is going to be f of x, and in which this is what you need to do here is enter and type in the actual polynomial that you're trying to factorize. Now, for this, the key that you should have an x button, like a variable x button on your calculator. It won't be the times because that's going to be completely different, and you'll probably come up with a syntax error for that. So there will be a function for you to use x. Now, on an older calculator, not the FX991EX calculator, what you might have to do is press the alpha button first and then select the closing bracket. Obviously, Different calculators have different options, but they should have a letter X on there for you to enter the variable X. If you've got the FX991EX calculator, you can just press, there's a designated X button just underneath your on button. So once you've entered your your polynomial, you then press equals or execute, depending on what calculator you've got. It then may ask you for another function because you can actually do two functions at the same time. We'll just bypass this. So if you just press execute or equals, it will just ignore it. Now the next thing we then move on to is the start. Now what you need to enter here is the smallest factor of d that you've got. Now this obviously will be a negative number, so you enter your negative number. So for example, if we go back to the example I used earlier of if d was positive 3, then our factors would be plus or minus 3 plus minus 1. So from that, what I would then do is I'd use minus 3. For your end value, you want to use the biggest factor you've got, which in that case would be the positive version, so it would be positive 3. Now the step, now this is the increments of your x values that you want to test. So in this case, because we want to use integers only, we would use 1. If we wanted to go up in halves, then we'll do 0.5. If I wanted to go up in thirds, I would do 0.3, which I wouldn't encourage, etc. So you can decide in what detail do you want those spaces to go into. Now, one thing to bear in mind is that this table function only allows for certain numbers of x. So if your range of values between your start and your end value is going to be quite big, your calculator might not like it. So just be wary of that. You might have to tinker with the end and the start values of doing this. It is a bit of a faff. Mathematically, I probably wouldn't choose this method, but I know a lot of students do, and obviously if a question's quite nice and easy, particularly if it's a multiple choice question, then this would definitely be a good option for you to choose. And then obviously what you then end up is with a table of two columns, one being your x values, the other being your f of x values. Now your f of x values are the values of the polynomial once you've substituted the respective x values. So what you're looking for there is you're looking for which values of x give you an fx value of 0. If you know, should be one, at least one that you'll find. So you find 1, find 2, find 3, and they'll be your 3 brackets. So for example, if let's say minus 1, when x equals minus 1, fx equals 0, then x plus 1 would be one of your brackets. If when x was, let's say, 4, and its respective value was 0, then x minus 4 would be another one of your brackets, and so on. So doing it this way can be quite easy if you've got a nice polynomial. What I'll do now is go through a few examples, like I said, where this does and does not work. So what I've done here is I've copied the steps on how to enter this on your calculator, and I've chosen 6 examples for us to work through for this particular method. So looking at step 1, we've got the equation of we want to factorise fully x cubed plus 2x squared minus 5x minus 6. So we can do this on our calculator, or have at least attempt to do this on our calculator, which I've got one of the older versions of the Casio calculator, but I'm just going to show that it doesn't really matter how old your calculator is, you should still have this table function. So if I press the mode setup button, then press option 3, which is the table, and here I've got f of x. So here, because obviously this calculator is quite old, there is a little bit of sort of faff that I'm going to have to do to enter this equation in. So I've got alpha x cubed, and then scroll across, and then I've got plus 2 alpha x squared plus minus 5x minus 6. So one thing you want to bear in mind is make sure you're entering it on your calculator carefully. Sometimes if you're not aware of what's being typed into your calculator, sometimes it can continue as a power, so just be wary that you have typed it incorrectly. Then obviously once you're happy with that, we then press equals. Now start value in this case, so what I'm looking for is I'm looking for factors of minus 6. So if I look at what those factors of minus 6 is going to be, then what I've got is I'm going to have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So obviously there are 8 possibilities I'm going to have in terms of that. So I'm going to start off with the smallest, which here is minus 6. Now, and my end value is going to be positive 6. and hope that the calculator can cope with 13 values. And obviously the steps, I'm going to go up in ones and press equals. Now as you can see here, I've got my x values going from -6 all the way to +6, and next to that column I've got my f of x value. So when I substitute these numbers into that polynomial, this is what the answer is going to be. So using the fact theorem, what I'm doing is I'm going to look for values of where it's 0. So scrolling down through this again, because I've bypassed it. So I've got one at -3. I've got another one at -1. And I've got another one at +2. So what I've got there is, just bear with me, and so here, let's change the colour pen. So for number 1, I've got that where it's equal to 0 is f of -1. I've got f of 2, and I've got f of -3. So what that, and all of those all equal 0. And so from that, what I then do is a is going to equal -1, a is going to equal 2, a is going to equal -3. So what my three factors are going to be is x plus 1, x minus 2, and x plus 3. And what I've done is I've very quickly factorised that cubic polynomial into 3 fractions without doing very minimal fuss. Now one thing I would do when it comes to an exam is make sure you are writing this, because what the examiners are going to want to see is that you've made an attempt at substituting those values into the function. So make sure, even if you get 3 done and it's perfect, it's just pure coincidence, they just want to see that you have actually substituted those numbers in and gone from there. Obviously, if it's a multiple choice question, then you're just ticking the right option. You can just expand it really. If it's multiple choice, you can work backwards. But where the marks are going to gain from, you get marked for each bracket. So that would be worth 1 mark, that would be worth 1 mark, and that would be worth 1 mark. So it's definitely worth doing. So if I repeat the process for this time step number 2, then again, if I get my calculator out again and just reset it. So what I'm going to do is I'm going to kind of alter this one just to save a bit of time, which you probably won't. So let's just reset it. So what I'm going to do is enter this calculation in. So I've got alpha x cubed, scroll across, minus 6 x squared minus x plus 30. Now as you can see in this particular example, I've got quite a lot of factors I could possibly have. So for example, I could have, and again this is where another flaw comes from using this, is that here I could have plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 6, plus minus 10, plus minus 15, and plus minus 30. So there's quite a lot of factors I'm going to go for there. So with your calculator only allowing you to do certain values or a certain range of values, then you've kind of got to guess. So I'm going to go for something a little bit more standard. I'm going to go for nothing more than 5 and just hope that I just coincidentally get it right. So I'm going to go for minus 5 and positive 5. And I'm going to go in steps in 1. So press equals. Again, what I'm going to look through is try and find as many zeros as I possibly can. So here I found 1, which is f of minus 2. So if I just write that down, so f of minus 2 equals 0, and go back to the calculator and trying to find another one. So I've got f of 3, so f of 3 equals 0, and back to the calculator again, and I've got f of 5 equals 0. So what that basically means is that a is going to equal minus 2, a is going to equal 3, a is going to equal 5. So my 3 brackets are going to be x plus 2, x minus 3, x minus 5, and there I've factorised that particular question. Now, this is where it starts getting, as you could probably tell, there isn't a noticeable difference apart from the numbers in most of these questions. So apart from when it starts going on to like question 6, where you're missing a few sort of degrees of x, so you're missing an x squared, you're missing something with an x, and so on. There isn't very noticeable difference between 3, 4 and 5. However, there is a massive difference, and this is where this method kind of gets its flaw. So before I continue, if I just wipe all of this off to give us a bit of room, and let's just get rid of that so it's not distracting. And so yeah, so what I'm going to do is I'll go through the exact same method with question 3. However, there is going to be a noticeable flaw that we have in this method. So if I go back to my calculator, reset it and reset that. So I'm going to enter the calculation again. So alpha x cubed, scroll across, plus 5 alpha x squared plus 8 alpha x plus 4. So here I'm looking for factors that are going to be of positive 4, so it's going to be plus minus 4 being the biggest, so I'm going to go for minus 4, and oh, missed a step there. Let's have a look what it's done. That was pretty quick. Yeah, that'll do. So as you can see, as I'm going through these list of numbers, a bit too fast, so I'm looking for factors of where it's going to equal 0. So I found one at minus 2, I found another one at minus 1, and lo and behold, there isn't another one. So here it's only allowed me to find 2 factors. Now when you come on to factorise a polynomial or cubic equation in this case, I'm probably looking at a maximum of 3 brackets. However, this method has only found me 2 of the factors. So it's found me a factor at, just go back to it, at minus 2 and minus 1. So with number 3, so if I just get the pen. So for number 3, I've got f of minus 1 and f of minus 2 equals 0. So what I've got is I've got x plus 1, x plus 2, and I'm thinking, where is it going to be? Now, as we've talked about, the cubic equation can either intercept at a maximum of either once, twice, or 3 points. That's how many brackets you're going to have. There's definitely going to be at least one factor that's definitely going to cross. So for example, my polynomial could look like that, in which I've got 3 brackets. It could look like that. We've already got one factor, and I'll try and do this one because this is the one I was trying to do, like that, in which I've got 2 factors. So the number of intercepts is how many brackets you're going to have. Now in this case, it's quite difficult because I've only found 2, and this is where the flaw is going to be. Like, how do you then find the next one? So again, this is where this method is kind of flawed, and the same thing applies with if you looked at number 4. Now, if you were to look at number 4, what you would find is that there's only the calculator from plus or minus 8 would only give you one root, and that root being when f is 2 equals 0. So what you've got is you've got that. Now, you don't know if it's going to be that cubed or if it's just that, or there's only one. Well, looking at the 3 possible options, it's only going to be the fact that there's only going to be one root in there, but there it is. So, or it could be something that can't be factorised. So it could end up where your 2 roots are going to be surd, so you can't factorise it. And again, this is where this method is flawed. With number 5, again, you go through the steps and you'll find you've only got 2 factors. So here you've got f of minus 1 equals 0 and f of positive 1 equals 0, and again you're missing that third option. So where is that third going to be? Is it going to be like one of these, or is it a case of where it's not going to be the case? Now I would say for this, as you found 2, you're definitely going to have a repeated root, but is it going to be where you've got 1 plus 1 squared x minus 1, or is it going to be x minus 1 squared x plus 1. We really don't know. Without actually going on to plot it and recognizing what the graph shape looks like, we're going to struggle. And likewise with regards to number 6. Again, you'll definitely be able to find one factor, but then the flaw in this is what happens if one of the factors was this. Now in step 5, one of the brackets is definitely going to have a 2x, because the only way you're going to get 2x cubed is if you're multiplying 2x by x by x. So one of the brackets must have a 2x in there. So if you, let's say, had 2x plus 1, then f of minus a half would give you 0. If I had 3x plus 2, then f of 2/3 minus 2/3 would give me 0. Now again, me trying to find that out on my calculator is going to be near impossible if I'm just investigating whole numbers. So as I've said, use this method with a little bit of caution. For simple ones, it's worth having a look, but if not, I definitely would not choose this option to factorize a cubic equation fully. However, the first step for the other two methods will be finding the first factor, in which this method is really good. Using your calculator is a much easier way of you finding that first factor rather than you guessing. So one thing to take out of this particular method is, one is make sure you know what numbers to try when you are using the factor theorem, and it's always going to be a factor of this number, the constant at the end. So pick and choose your factors. As a hint, always go for the smallest one first as a starting point, because you tend to find that with these questions, examiners aren't wanting you to spend 20 minutes to do one question, so they want you to easily find that first factor, because there's time limitations on exams, there's time limitations on textbooks, etc. So feel free to try the smallest ones first and then move forward. So as I said, this is one way of doing it. You might find it works for others, but trust me, it is not a foolproof method that works for every single question.